This video is for lesson 8.2, solving two-step equations. Before we begin solving two-step equations, here's an example of a two-step word problem. I would like for you to solve this using whatever strategy you already know how. To solve this problem, you would need to start by subtracting 290 pages minus 110, since that is the total number of pages that Keegan has already read, leaving you with 180 pages left. And then you would need to divide 180 pages by 20 pages a day to get a final answer of 9 days. This is an example of a two-step problem. We can obviously solve this without algebra by just those two steps that I just showed there, but we are going to be working on how to solve problems like this algebraically. So when we're solving a two-step equation, same goal as when we were solving a one-step equation is to get the variable by itself. So we will be using the inverse operations again. If it shows addition, we do the opposite, which is subtraction, or multiplication and division. What's really important here is that we will always add or subtract first, and then multiply or divide second. And if you look at the example that we just did, you'll notice that we, in fact, subtracted first and then divided. And that's important that when we're solving these two-step equations, 99% of the time, we add or subtract first and then multiply or divide. So let me show you an example of a two-step equation. Here we have negative 3x minus 4 equals 11. Our goal is to figure out, of course, what does x equal so that this whole equation, negative 3x minus 4, actually equals 11. So a little bit harder to do these in your head than the one step. So what we need to do is we need to isolate the variable. We want to get the x by itself. This is negative 3 times x, and this is minus 4. So when we're trying to get the x by itself, we want to start by adding or subtracting the number that's on the same side of the variable. So we have a minus 4. To cancel that out, we need to do a plus 4. So we're going to add 4 to both sides first. What that does is that cancels the minus 4 on the left, leaving us with this whole negative 3x term. So we're not quite there yet in terms of having x by itself because we still have the negative 3, but that's okay. We're just going to take a second step to get x by itself. And then on the right side, we have 11 plus 4 is 15. And then we need to do negative 3 times x equals 15. We need to get the negative 3 to cancel out. So since it's negative 3 times x, we'll do the opposite of multiplication, which is to divide by negative 3 on both sides. Negative 3 divided by negative 3 cancels out and leaves x by itself. And then 15 divided by negative 3 is negative 5. Let's try another example. Make sure you're writing these down in your notes. Okay, in this example, our y, our variable, is on the right-hand side. Negative 7 equals 8 plus y divided by 3. We're trying to figure out what the y equals so that when I divide it by 3 and add 8, we get negative 7. So first thing we want to do is we want to cancel out this 8. To cancel out an 8, we want to subtract 8. We want 8 minus 8 to equal 0. And on the left-hand side, we're going to subtract 8 as well. So remember, when you do something once on the right side, you also do it once on the left side. Negative 7 minus 8 is negative 15. Be careful with these negatives. If you're not 100% confident in your adding and subtracting with negatives, double check yourself on a calculator. That's not a problem. You're allowed to use a calculator. And then here we have y plus 3. We still need to get rid of the y divided by 3. So remember, to get rid of divided by 3, we multiply by 3 over 1. And we multiply by 3 on the left side as well. The 3's cancel. Y is by itself now. 3 times negative 15 is negative 45. So y equals negative 45 in this second example. Okay, before we move on to the second set of examples, the last two examples in your notes, let's try some of these on your whiteboard or on a piece of scratch paper and choose the correct answer. For question number 1, you should do minus 10 on both sides. That'll cross out this 10, and you end up with negative 12 equals 4h, and then you divide by 4, which gives us an answer of negative 3 equals h. For our second example, this one's a little bit tricky. You actually want to subtract 5 here. 5 minus 5 is 0. And then 8 minus 5 is 3. Now on this left-hand side, here's the tricky part. We didn't do an example like this yet. You want to bring down the minus sign with the 3x. So it actually becomes a negative 3x, not a 3x. So you want to be very careful with that. That minus sign goes in front of the 3x. So it's a negative 3x, which means we have to divide both sides by negative 3, not 3. So our answer is negative 1. And for our third example, start by subtracting 3 on both sides. So you end up with negative d over 2 equals 1 minus 3 over here is negative 2. And then we're going to multiply both sides by negative 2. These cancel, the negatives cancel, d is by itself, and we get negative 2 times negative 2 is positive 4. So really the hard part about these mostly are the negatives. You have to be very, very careful with your negatives. Okay, let's take a look at an example 3. These are in your notes. So here we have 9 minus x equals 6. We want to first cancel out the 9. We're trying to get x by itself. So if I subtract 9, 9 minus 9 is 0. Be careful that you don't confuse this subtraction sign for to add 9, because 9 plus 9 isn't 0. Remember, we want it to equal 0, so we have to subtract 9. This minus sign actually goes with the x. So just like in that second example that we just did, this becomes a negative x, not an x just yet. So 6 minus 9 is negative 3. And then here's our final problem here. We have negative x equals negative 3, but we don't want negative x, we just want x. So if negative x equals negative 3, then positive x would equal positive 3. So we have to just rewrite our answer, flipping both of the signs so that we have x equals 3. Okay, and example number 4 is our example involving fractions. So we have 13 equals negative 5 minus 3/4 times k. Start by adding 5 to both sides, so that a negative 5 and a plus 5 cancel to 0. And what we're left with is this minus 3/4 k, which becomes negative 3/4 k. 13 plus 5 is 18. And then if you remember from our lesson on what to do when our coefficient is a fraction, you're going to flip it to negative 4 over 3 and multiply both sides by negative 4 over 3. So over here, remember, we want to get the k by itself. So the 4's cancel, the 3's cancel, k is left by itself. And over here, we can multiply negative 4/3 times 18 over 1. You can cross simplify if you want. I suggest it. Negative 4 times 6 is negative 24. Okay, take a few minutes to try these examples here. Example number 1, you're going to start by subtracting 2 from both sides. 2 minus 2 is 0. 1/5 w stays. Negative 3 minus 2 is negative 5. And then to get w by itself, we multiply by the reciprocal of 1 over 5, which is 5 over 1. This cancels, so w is by itself, and we get negative 25. For your second example, you're going to start by subtracting 8 from both sides. We have a minus y becomes a negative y, and 10 minus 8 becomes 2. So if negative y equals a positive 2, then a positive y equals a negative 2. We just reverse the signs on both sides.